Alrighty, in example 3, we are going to take the time to evaluate f of -2 using our function from example 2, the off chance that we didn't get to it in class. So we are going to have -2 in our box, and then we have all of our coefficients going across the top. So I always like to write them in, okay, if I'm starting with x cubed, then I just make a small note up top, okay, x cubed, x squared, x, and then my constant. So my coefficient of x cubed is what I write immediately to the right of -2 in my box, which it's just a negative, so it'll be -1, right? Because there's always that invisible 1. With x squared, my coefficient is -3. My coefficient of x is 9, and my constant is -5. So then I leave myself a little bit of room, draw on my line, bring down that -1. I multiply -2 times -1, and I get +2. And then I add -3 plus 2, I get -1. I multiply again, -2 times -1 is +2. I add, I get 11. And I multiply -2 times 11, I get -22. And I add, so -5 plus a -22 gives me -27. So apparently f of -2 is -27. Now we're also going to jump ahead and talk about example 4. So hopefully we got through all of our notes other than potentially this one, or if not, if we did, here's a nice refresher. So from example 4, we want to use our graphing calculator to graph this f of x and include a sketch below, clearly indicating your viewing windows. Describe the end behavior and the reason for this. Let's go ahead and start with that, and we'll work our way backwards, talking about what to expect from our graph. Well, remember that our end behavior describes what happens as our x goes really, really far to the left and really, really far to the right. So in order to determine that, I use my chart from up above, and I look at my leading coefficient and my degree. My leading coefficient is -1, technically, but more importantly, it's negative. That's really all I care about. My degree is the highest exponent I see. Let's confirm it's in standard form. Okay, good, it is. So my highest degree is my largest exponent, which is 4. And again, having the number is great, but really what I care about is that it's an even number. So our leading coefficients that are negative and our degrees that are even, those polynomials are all going to have the same end behavior. So if we think about it graphically, if we include a quick sketch, negative leading coefficient and even degree, it's going to start low and low. So as I'm looking farther and farther to the left, we're going farther and farther down. So we'll say as x approaches -infinity, f of x is also going to -infinity, right? It's going down as we go to the left. Same idea off to the right. As I look farther and farther to the right, it's going farther and farther down. So then as x approaches positive infinity, f of x approaches negative again, which makes sense. When our degree is even, those two are always the same sign. So negative and negative in this particular case, since our leading coefficient was also negative. So now we'll pull up our graphing calculator and take a look at what that function will look like. Alrighty, as we want to enter in this graph, we know we're going to want to go to our y equals. So if your stat plot is not already off, so if you have plot 1 highlighted, you can arrow up and hit enter to turn it off. Mine is already off though, so we're good to go. So I'm going to arrow back down. Under y1, we will type in -x to the 4th plus 3x raised to the 3rd power. Remember, we're using this little caret button just underneath our clear button. Plus x squared, and then this time around we have a nice squared button ready to go for us, -8, and we'll hit enter. So before we know what we need our windows to be, what we need our x and y to be scaled by, we can take a look at our table feature, remember, to give us a clue of what our values are going to be. So if we hit second graph, notice it says table. We'll take a look at some of these x and y values. As we arrow up and down, we can see how wide our range of values will be. So just at -5, we have -983. This function is going to be huge. And then notice as we get closer to -3, -2, -1, our y-coordinates are looking a little more reasonable. Now, remember, with our end behavior, we expect it to go to -infinity as we go off to the left and the right. And yep, that is for sure happening the farther left and right we get. So, as we're looking at our window, I would suggest an x-min and x-max really just from -5 to 5, because we know that it's going to shoot way down if we go too much farther past that. Honestly, it shoots down pretty far at -5 and +5. And then for our y-min, maybe we'll go down as far as -20, right? We know a lot of it is negative, and then we can probably just go up to 5. Counting by ones, that's probably fine. Let's take a look at our graph. There it is. How nice. Oh, rats, wasn't quite tall enough. So let's see if we can't get that max value. So for our y-coordinate, maybe let's go up to maybe 8 or 10 even. And this time around, maybe we'll count by 2s. Come on, yes, alrighty. So we now know approximately what our graph looks like. So we will go ahead and sketch that back on our notes. Alrighty, now that we have that graph pulled up on our graphing calculator, let's go ahead and include a sketch right here. So it looks like our graph ended up looking kind of like this-ish. And we went from -5 to 5 on our x-axis, -20 up to +10 on our y. I'm gonna make this just a little bit bigger, perfect. And then our graph kind of had this general shape. We went down, and then we kind of crossed, and went up and down. Now, we want to make sure that we give, yes, our windows, so that's always important, but it never hurts to label a couple points on your graph as well. I would always vote for x-intercepts, y-intercepts, and then maxes and mins would never be bad to include either. So if we just hit trace and type in 0 for x, we can find our x-intercept is -8, which makes sense for us because that's also our constant value. This 0 right here looks like it is 1.57, comma 0. Again, we can use our second trace 0 feature, which is option number 2. And then second trace maximum for this feature here, or to find that max point, that would be 2.54, comma, nope, 2.454, sorry. So 2.454, 6.091. And then lastly, we can label this 0, 3.045, comma 0. So the more information you can include with a sketch, the better. That's also a good indicator for me that you understand how to use the trace features and the second trace features of your graphing calculator. So more labeled points is never a bad thing.